Okay, so I guess just a bit of an introduction for myself, I guess. So I'm Alex Dickson. I work for Ballance. I'm in the horticultural team on the East Coast, based in Hastings. So Dan's asked me to put together this presentation in terms of just how to interpret a soil test, but with a bit of an emphasis on what we might be looking for asparagus. So as a bit of an overview, just want to touch on why we soil test. Dan has quite nicely covered some of the ins and outs of the depth that we might be testing to. So I guess where I'm kind of presenting, or what I'm presenting on, is what to do after you've got the results from that soil test. I've focused on three main nutrients, so nitrogen, phosphorus, potassium, and then looked at pH as well, but also just included a little bit of information on sulfur and magnesium. In general, not too worried about these nutrients for asparagus, but I think it's worthwhile just noting. And then for each nutrient, have covered what it does in the plant, and then how it's measured and what it looks like in a soil test. So I've included soil test results from Hills, ARL, and Eurofins. So depending on who does your soil testing, it kind of gives you a flavour for what the report looks like. So why do we soil test? So soil health is made up of three properties. So you've got chemical, physical, biological. Chemical properties, or the chemical properties, is what we're looking at largely with a soil test, but for some of the new soil tests we can look at some of the biological factors as well. So looking at tests that act as a proxy for soil biology, so hot water extractable carbon and an anaerobically mineralizable N. Physical properties are largely tested through visual soil assessment, so digging a hole and actually scoring different characteristics against a bit of a sort of a ranking essentially, which can be very useful. So certainly not looking at soil health in a silo in terms of chemical health or looking at soil testing. There are other things that we're considering as well. So key nutrients that we'd be looking at in a soil test is your nitrogen, phosphorus, potassium, sulfur, magnesium, calcium, and sodium. When looking at a soil test or looking at the nutrients available to plants, we're looking at we're working with a principle is the law of the minimum. So plant growth will be controlled by the biggest limiting nutrient. So essentially, potential growth will be limited by what's the biggest hole in the bucket. So if there's a deficiency in one nutrient, so it might be potassium, then that will be the limiting factor to plant growth. Trace elements, so they're listed there, your zinc, manganese, moly, boron, all important for plant health. Boron's the only nutrient or only trace element that would test for accurately with a soil test. The rest of the trace elements really need to be looked at in a leaf test. I thought it would be important just to touch on nutrient removals. So just to contextualize what actually is coming off the paddock when removing an asparagus crop. So this graph, also not graph, table comes out of the asparagus manual. So just compares asparagus to maize there and shows what you might be removing in terms of nutrients. So the main nutrients that are coming out are nitrogen and potassium. Small amounts of phosphorus, sulfur. We do need to be careful when removing any product from an area, be it a vegetable or if it's meat, wool, milk. Whenever you're removing product, you are removing nutrients and do need to be careful to replace these over time to make sure we're not mining it out of the soil. So all of the nutrients there that we're concerned about for asparagus can be tested through soil testing or monitored through soil testing. So if we move on to nitrogen, so probably the most widely discussed nutrient and potentially the most controversial. So nitrogen is required by both plants and animals for protein synthesis and is really key for DNA and enzyme production. It's essential for the production of chlorophyll, which is of course the green pigment that we see in plants, and absorbs the light energy required for photosynthesis. Despite the noise and the controversy around nitrogen, it is actually essential to life for us and for plants. It's the most mobile nutrient, so that's why it's very leachable, but also quite readily taken up by plants. There's different ways to test for nitrogen in the soil. So Dan briefly touched on quick N testing. The test that we more commonly do from a lab point of view, so the Hills, Eurofins and ARL will be potentially available N or your anaerobically mineralizable N. So same test, just different way of wording the name. Total N and deep mineral N. So I'm going to touch on potentially available N and deep mineral N or mineral N testing. Most of the soil nitrogen exists within organic matter. There's only a small percentage that is plant available. For plant availability, nitrate is the most available form to a plant and is taken up most readily, followed by the ammonium form and then the urea form. Plants can take up a urea form of nitrogen, but more commonly it will be converted to an ammonium or nitrate form and then taken up. So if we look at mineral N tests, and I think these are probably the most useful test when looking at crop side dressing or applying N, and it's potentially with a quick N test, but it's looking at a soil available N at a snapshot in time. So it tests for the ammonium form and the nitrate form to give you a total mineral N. So that's the nitrogen available to the plant at the time of testing. There's a calculation there. There's two sort of examples from the tests below. So the Eurofins test was done to a 150 mil depth, so 15 centimetres, and the Hills one was taken at a 600 mil depth. So there's a wee calculation there, and I'll make sure that these slides are sent out for future reference. But basically the nitrogen that's expressed in the soil test can be converted into kilos of nitrogen per hectare. You can see that there's quite a big difference between the two examples, and that's really driven by soil test depth. So one's at 15 centimetres and one's at 60 centimetres. So I'll make sure that's sent out, but it is a good way of measuring what's available and what the plant's going to require. So therefore what applied N needs to go into the system. It's really important, whoever's doing these tests, the sample actually needs to be kept really cold, so at 4 degrees Celsius, otherwise nitrogen will continue to mineralize and it won't give an accurate reading for the test. So when I do these tests, I soil test with a cooler or chili bin and ice packs, and then refrigerate them and send them the next day just to make sure they get to the lab at that temperature. And the labs will they will test the temperature of the sample on arrival. Mineral N can be influenced by a range of factors, so soil type, crop type, organic matter, the pH. So it is, there's a lot of influences on what the mineral N might be. As Dan mentioned, you can do these tests at different depths. The 15 centimetre depth will have more comparable information on it, but the 60 centimetre depth is good when you're looking at what's available for the total area of the root and for a plant. So often done for maize, but I guess can be certainly done for asparagus as well. Potentially available N is the other test that I just wanted to talk about, and this is more a measure of the amount of nitrogen that might be made available over the life of a crop. So it could really be done with your basic soil tests at the beginning of the season. And this can just be added into your basic soil test. So the sample is incubated for a week and it mimics what would happen over the life of a crop, essentially. So the test is expressed as kilograms of nitrogen available per hectare. So that can be used at the beginning of a season to figure out and there's a bit of a calculation there, how much nitrogen needs to be applied for the season, total nitrogen required for the crop and then take off the amount of potentially available N that's available, and then that will give you how much N needs to be added if any. There could potentially be a surplus if the potentially available N is high. So the test that I've included is from a maize paddock, I think. So to put it into context, this would probably be sufficient nitrogen for an asparagus crop, but potentially not enough for a maize crop, which has a high nitrogen requirement. Are there any questions at this point in terms of N?
That's good.
Cool. Just, I guess, because there's only a couple of people on, if you want to butt in with questions, feel free to do so.
I'll just touch a question there. Your potentially available land, you said, was what's available to the crop over the season, and you did it using the anaerobic test.
Yes.
Is it the nitrogen that's just provided by the mineralization, or does it also include the mineral nitrogen?
I think it's the, I'd actually have to check that. I'm fairly sure it includes the mineral nitrogen, so it's everything that would be made available basically in that period.
Yep, that makes a lot more sense to me now. Thank you.
Okay, I can certainly send out there's a fact sheet on potentially available N that I can send out when I send my PowerPoint, if that's helpful.
I would be interested.
Sorry?
I would be interested.
Okay, I will make sure that that gets sent out as well. So if we move on to phosphorus, phosphorus is a really key nutrient for the early stages of plant and especially root development. So if you're growing any crop from seed, normally phosphorus would be drilled with that crop, and that is to make sure that root development and establishment is really good in that early sort of stage of crop. In the plant, it's important for the formation of ATP, adenosine triphosphate, which stores the energy for metabolic processes in plants and for animals as well. When removing any product, as I've touched on before, you'll be removing nutrient, and phosphorus is one of those key nutrients which needs to be replaced. The other thing to note here is that phosphorus leaches in very small amounts compared to nitrogen, which is because phosphorus is held within the soil profile much better than nitrate nitrogen. Phosphorus is generally lost through soils, also surface runoff, and through erosion. So the main way that we test for phosphorus in New Zealand is through Olsen P. It's the most well-researched soil way of, sorry, I'm recovering from COVID. I'm just having a bit of a tickly throat. So the most well-researched P test in New Zealand, it's used globally. It's calibrated to New Zealand soil conditions and widely used. It measures plant available P compared to just down the bottom there or the middle of the paragraph, there's resin P, which looks at a more slowly available form of P. It can be expressed in a test as either milligrams per litre or micrograms per mil. You'll see that Hills is micrograms per litre and then ARL is milligrams per litre and micrograms per mil, but it is essentially the same. So they can be compared. However, comparing between labs, there will be subtle differences. There's not really enough research from what I could read on what the optimum levels would be for asparagus. However, for most crops, an Olsen P of around 30 would be appropriate. So maintenance requirements for phosphorus might be between 10 and 30 kilos per hectare per year, which, while it won't be a high rate of fertiliser use, it is still important to make sure that those maintenance requirements are met. Potassium is the next nutrient that we'll look at. It's important for controlling the water and electrical balance within a plant and involved in carbohydrate and protein synthesis. Potassium is taken up through luxury uptake, so the plant will take up more than is required, which is one of the reasons that there's it's normally the highest or the most nutrient is removed is in potassium. Most soils have large amounts of potassium in total. So from the fractions here, we're going to be looking at the exchangeable form of potassium, but there's also tests that we can do for this fixed form of K. Asparagus removal is not high in potassium, however, it is the nutrient that's moved in the largest amount. So it can deplete levels over time. I guess it's key to note that this is really dependent on soil type. For instance, in Hawke's Bay, sedimentary soils can have quite high background total K levels, or fixed K, but areas like the Central Plateau, the pumice areas there will have quite low background potassium levels. So the way that we would look at potassium on a soil test is through a quick test or a math test. So you can see between the three labs that they're all given in similar sort of units, math quick test units and math units. It's measuring the exchangeable form of K or the plant available form of K. And the results are reasonably easy to compare between the different labs. Total K is measured through TBK, which you can add to a basic soil test, and that measures your reserve. So if you had a low plant available K level, you could do a TBK to see what the reserve levels of K might be in the soil. So that's the ability for the soil to continue to supply potassium. A 5-ton asparagus crop based on that table at the start would remove 20 kilos of K. So over time, that would potentially deplete potassium levels depending on soil type. So that's really key. So sedimentary soils will often have a high TBK and will almost replenish themselves over time versus pumice or volcanic soil, which might have lower potassium levels. Based on the asparagus manual, a quick test level of 10 is recommended, but I think you could match that with a leaf test to see whether there was enough potassium being supplied to the crop before going and applying high levels of potassium to correct any soil deficiencies. Potassium is also quite an expensive nutrient to apply, so certainly want to make sure that it is definitely limiting before going and putting capital amounts on. So then want to look at pH just quickly. pH is essentially a condition of the soil and is measured from a pH of 1 to 14. New Zealand soils generally fit between 4.5 to 7, but if you're aware of the sort of area around Napier Airport where the earthquake brought the land out of the ground, there's certainly soil pHs that are around 8.5 on some of the marine clays, so it definitely can end up with extremes. Optimum for asparagus is about 6, which is standard for most crops. The only, and pasture as well. There's certain crop types where lower pH would be advised. So that would be potentially with potatoes, where low pH reduces the incidence of scab, and for blueberries, which don't take up manganese particularly well. So a lower pH is preferred by blueberry. Acidification of the soil is a natural process. So naturally the soil will reduce, or the pH will reduce over time. And that's just through microbial activity, leaching, organic matter breakdown, and fertilizer use is one. So some fertilizers are acidic, and there's ways that you can sort of work out what the acidification from a fertilizer might be, but it's likely there'll be more acidifying factors going on beyond that. The table on the right just shows different nutrients and their availability at different pHs, which I think is it's good to note that as you move up towards that 6, that a lot of nutrients aren't necessarily at their most available, but it's at the most available without reducing the availability of other nutrients, and that's why 6 to 6.2 is probably the most ideal pH. So the last couple of nutrients that I wanted to touch on was sulfur and magnesium, which aren't required in large volumes for asparagus, but certainly will come up on a soil test and is worth noting. Sulfur can be measured in two ways in a soil test: through sulfate sulfur, which is your plant available form, and an organic sulfur, which is normally given as EOS. So that's a more slowly available form of sulfur. This will be really dictated by soil type in particular. So ash soils might have a higher sulfur content compared to a sedimentary soil. The sulfate sulfur is the one that will normally show up on a soil test in a basic soil test. Magnesium levels are measured through a quick test in MAG or math, like a potassium test is done. Asparagus again have low MAG requirements, however, you'd want a quick test above 8. So you can at least look at a soil test and know whether some magnesium is required, but typically not really an issue. For sulfur, if fertilizer is being applied, a lot of fertilizers have a sulfur component, so it's likely that this nutrient will be met through other means anyway.